Picture this. A fighter jet lands, refuels, reloads missiles, and takes off again, all in less than 10 minutes. While other advanced jets like the F-35 sit grounded for hours, Sweden's Gripen is already back in the air, hunting its next target. What allows this tiny fighter to outperform giants in readiness? The answer isn't raw speed or stealth. It's a revolutionary engineering philosophy built around efficiency, modularity, and adaptability. During the height of the Cold War, Sweden faced a daunting strategic dilemma. Officially neutral, the country was sandwiched between NATO allies and the Soviet Union, with vast Arctic territories to defend and a defense budget far smaller than its neighbors. Conventional air bases were obvious targets for enemy strikes, meaning any centralized infrastructure could be destroyed in minutes. Sweden's solution was radical: reimagine the battlefield itself. Roads, highways, and short improvised strips became functional runways, hidden within forests and remote landscapes, ensuring the Gripen could operate even if traditional bases were obliterated. This wasn't just clever thinking, it required rethinking the entire aircraft, its maintenance, and its operational philosophy. Every system, every panel, every engine component had to answer one critical question: could it work anywhere, under any conditions, with minimal support? The BAS-90 system envisioned Gripen fighters operating from 500-meter stretches of road, hidden in forests between missions. But this created an impossible engineering challenge. How do you maintain a sophisticated fighter jet in the middle of nowhere with minimal equipment and inexperienced personnel? Sweden's conscript military model meant 18-year-olds with just months of training would need to service these aircraft. No massive ground support equipment, no specialized facilities, no veteran technicians. This wasn't merely about building a high-performance fighter. It was about completely reimagining what a fighter could achieve under extreme conditions. Every bolt, panel, and system was scrutinized with a single question in mind: could a small, minimally trained team maintain this aircraft under a forest canopy, in freezing weather, with no hangars or heavy equipment? The answer demanded ingenuity at every level of design. Gripen's extraordinary design makes this possible. For air-to-air missions, the aircraft can land, refuel, and reload in less than 10 minutes, handled by just one trained technician and 5 conscripted soldiers. Air-to-ground sorties take under 20 minutes, a staggering contrast to jets like the F-35, which require extensive crews, specialized tools, and far longer downtime. The secret lies in obsessive modularity. Every access panel is easily removable. Weapon stations accept munitions without complex setup. Even the auxiliary power unit ensures independence from external power, enabling hot refueling while engines remain running, turning what would normally be hours of preparation into mere minutes. Need to swap the entire engine? 1 hour with simple tools. Replace the radar? Same time frame. No fixed installations required. Saab engineers designed every component asking, can this be done roadside? The ultimate proof? Everything 2 Gripen fighters need for a 2-week deployment fits in a standard 20-foot shipping container. Meanwhile, deploying 2 F-35s requires cargo planes full of equipment. This isn't just convenient, it's survival. Dispersed operations mean enemy missiles can't destroy your entire air force on the ground. You're hunting from highways while adversaries bomb empty air bases. For single-engine fighters, engine reliability isn't optional, it's existential. When Sweden commissioned Volvo Aero, now GKN Aerospace, to adapt General Electric's F404 engine in the 1980s, they faced a daunting reality. The F404 had only flown in twin-engine aircraft. Losing one engine in an F/A-18, you limp home. Losing your only engine in a Gripen over the Baltic Sea, you eject. GKN Aerospace completely redesigned the engine, creating the RM-12. They thickened first-stage fan blades so bird strikes would deform them rather than shatter, resulting in only 6% thrust loss instead of catastrophic failure. They simplified systems, reduced weight, and obsessed over every potential failure point. The results speak volumes. Over 300,000 flight hours without a single engine-related accident. Not one. Robert Johannesson from GKN Aerospace revealed their secret. We don't just examine the specific module that fails during maintenance, we check the entire engine. This means we catch errors that haven't even been discovered by the customer. This proactive approach transformed the 12 Ringgit into arguably the most reliable fighter engine ever built. Gripen E demanded more power, so GKN Aerospace partnered with General Electric on the F414G engine, designated RM16 in Swedish service. This power plant delivers 20% more thrust than its predecessor, enabling supercruise, sustained supersonic flight without afterburners, at Mach 1.1 while carrying air-to-air combat loads. But raw power wasn't the only upgrade. The RM16 employs on-condition maintenance using real-time performance monitoring. Instead of scheduled overhauls that ground aircraft unnecessarily, sensors track actual engine health. Replace components when data says they need it, not when a calendar does. This approach proved itself in U.S. Navy service, where F414-powered Super Hornets achieved 80% mission-capable rates through targeted component improvements. GKN Aerospace's Trollhättan facility handles all RM16 maintenance, leveraging decades of RM12 experience. In 2017, they demonstrated future readiness by running the RM12 on 100% renewable biofuel. Both in-flight and ground operations performed flawlessly. The maintenance philosophy remains unchanged. Catch problems before customers discover them. Keep jets flying. Minimize downtime. Saab's marketing brilliance almost obscures inconvenient truths. When Canada's Department of National Defence conducted a rigorous fly-off in 2021, the results were stunning and recently declassified. The F-35 scored 57.113 out of 60 possible points. The Gripen E, just 19.762. In mission performance, the stealth fighter achieved 97% versus Gripen's 22%. Upgradability, 100% versus 28%. The pattern repeated across every category. Finland's HX fighter competition told the same story, with Gripen finishing third, even when supported by two Global Eye AWACS aircraft. Then there's the cost myth. Saab claimed $8,000 to $10,000 per flight hour, a figure from a 2012 self-funded study covering only fuel and consumables. Aviation Week revealed the real number, $22,175 per hour, including maintenance, still cheaper than the F-35's $30,000, but nowhere near advertised. Most ironically, Gripen's supposed independence from American suppliers is fiction. One-third of components come from U.S. manufacturers, including the GE engine and Honeywell life support systems. Those Rolls-Royce engine rumors? Just speculation with no confirmed development. Even with all these innovations, Gripen's true advantage isn't just engineering, it's adaptability. Engines like the RM12 and RM16, combined with modular systems, allow the jet to operate in conditions that would ground most fighters. Short strips, forests, and improvised bases are no obstacles. Every mission is supported by real-time monitoring, predictive maintenance, and rapid component swaps, turning downtime into opportunity. Gripen doesn't just survive, it dominates dispersed operations. Small crews can do what would take massive teams elsewhere, keeping the jet combat ready when others falter. In a battlefield where seconds decide life and death, this speed becomes more than efficiency. It becomes survival. Gripen's genius lies in speed, modularity, and engine reliability. While others depend on extensive logistics, this Swedish fighter proves that efficiency, foresight, and innovative engineering can turn even small crews into unstoppable forces on the battlefield. If you found Gripen's hidden technology fascinating, hit like, subscribe, and comment. Join us for more incredible defense technology stories that reveal how modern warfare is changing faster than you think.